Here's my project for today. Let's say I'm going to build this board, which is full of connectors. And you want to solder these connectors on the board. These are all through-hole parts on here. So you put a part on, put your finger on there, hold it on the board, get your soldering iron out, get your solder out, and somehow you miraculously hold all four of these things all at the same time. And these two pin headers are particularly troublesome because when you hold these guys, you're going to end up burning your finger because the heat transfers right through these pins. So I have a better solution for that. I'm going to show you that today. This is a 3D printed assembly jig for doing soldering parts on boards. This has got a lot of different compartments at different depths. So to build this board, you put all your parts on, and you put your assembly jig on, turn it upside down, and solder everything in. And this jig, I've determined all these heights for the different components that I have, and they're all the components are going to sit flush, and you can check that on the side here. And there's a little bit of an offset here, so you can actually look in and see how your parts are sitting on the board. If you'd like to see how I modeled this 3D printed jig, well, we're going to start right now. All right, here's the model for that APD jig that we just saw. And I'm going to go ahead and show you how I modeled this up using Fusion 360. Here's the board layout for the 8BD board, which is a octal dual triode 6S7. And what I want to show you is when I model these parts in the parts library, I made sure that the border outline for the parts actually measured exactly to the part. For the octal socket connector, the 2-pin header, as well as this 3-pin connector here. This version of Eagle allows me to export out a DXF file of the board itself, turn off things I don't need. I'm going to export it in millimeters. And there I generated a DXF file that I can import into Fusion 360. Let's first create a sketch on the top plane, and we will insert that DXF file that I created. And here it is right here. We'll bring this in. And so you can see over here in the dialog box that there's a bunch of DXF layers that we don't actually need. So let's go see number 20 is the board outline. We need that. 25 is the letter silk. We don't need that. 39 is the screw head diameter, the keep out region. We don't need that. 21 is the part outline. We do need that one. 200 is a board graphic. We'll take that off. 23 looks like drill holes. Something with vias. 16 is the bottom side copper, and 1 is the top side copper. And 18 are some via holes. Okay, so we'll start with this, and we also want to offset this from the origin. We don't want to be locked in the origin. We'll talk about why that is in a minute. Okay, so here's our, we're still on a sketch. We're doing on a sketch now. Now, I'm going to go in and delete a bunch of stuff that I don't need. So just kind of come in here. We're going to delete this stuff, and we'll you don't need to watch me delete all this, so I'll just speed this up right now. All right, so now we have our sketch here. And just from doing a bunch of these, I'm going to tell you that we need to make this outline a little bit bigger. So let's go back in and change that a little bit. We could just drag these corners up, and since I have this snap on, we'll go ahead and snap up to some corners so we can get these lines to be straight. So I'm going to come over here like that, and I'm going to move this one over. Okay, so it looks like that. That's probably a little bit too much. We just come back a little bit. Okay, so this one's pretty close. Now these are the exact borders of the parts So what we need a little bit of clearance in here. And so we can use the outline tool under sketch. Offset tool. We can pick that and then we can choose some offset here. But I don't want to type this number in all the time, so I want to show you what I ended up doing. Over here, you can see I've done a lot of these jigs already. And I'm using this thing called I'm inserting a design into the jig design files that I'm just calling master parameter. And if you look in here, there's no actual parts, there's no bodies, there's no sketches, there's nothing. Except for there's parameters in this file. And these are the various parameters that I need to do these jigs. These are measurements that I took and actually kind of printed a few of these things and got the spacings all correct. So what we're going to do over in our demo file is we're first going to come over and we're going to insert into here a derived file. We're going to pick that master tac file. And you can see here that I can bring in objects from that file, or down here under parameters, I can bring in the favorites. So I can bring in the favorites. Now if I come over to my parameters, you'll see that I have, oh, I didn't do that right. Let me do that again. In order for this to work right, I need to be up here at the top level. And we'll bring that back in again. Okay, so we're going to come down here, click on that, and bring in the favorites. And then now when I come down, you can see that it added this derived from the master parameter file. And if I come down to my parameters, you'll see that I have master parameters are brought in to this design. However, they're not actually in this design yet until I make them favorites. So I got to bring in the parameters that I want. I can bring them all in. And since we can drag things around in our timeline, we're going to need these parameters for the entire design. So I'm going to go ahead and slide that all the way to the front. And we'll save this now. Okay, so let's go back in and edit our sketch. And the first thing we're going to do is we're going to create those offsets using this tool here. And I can create a bunch of them all at once. Well, first let me show you something else here. So say I want to do an extrude, and I go and extrude this whole part, and I'm going to extrude it up. Okay, so remember now we're looking down from the top, so the parts are actually on the top of the board. And so if I did this way, okay, so now this is looking from the bottom side. Now if I extruded these parts back in and say that this is my jig, this border is not quite, it's the exact outline of the part, and we need to put a little bit of an offset in there for tolerance around the part. So let's delete that extrude and go back in. Let's go add in those outlines. And I always want to work on the top side of the board. This is me looking down onto the board. So I need to add these offsets in around all these perimeters around all the parts. So I think that I can come in here and select all these things. If I can do this here. I think I can just do it like this. Okay, so now I have all the part parameters. I can come in here and apply an offset to all of them. And I get an error down here that says it can't offset the curves. Okay, so let's do this again. We're going to select all the rectangles, and then we're going to deselect the circle in the middle, hit offset. Except I grab this line over here. Let me try this one more time. Turn that off, turn that off. Okay, so now I just have the inside perimeters highlighted, and I'm going to hit the offset key, And then what here, I have a parameter for this offset, and I think it's offset part reference. Oh, you also see that these parts came in with an underscore reference on it, which means that there is a it's coming in from my derived file. So that's correct. And now I can set this offset for this part. Same thing. I can name it offset part. And so now we have all the offsets in there. So we're going to do our first extrude. So finish that sketch. And we're going to extrude this up from the board, up by a height that I call height jig. And in this case, it's 16 millimeters. So this is what the jig's going to look like. And what we're going to do is we're going to push some of these down. We're going to extrude these down and do some cuts into this part. But first, let's go ahead and add some chamfers to this body, because we don't want all those sharp corners everywhere. And we'll make it one millimeter there. And yeah, so we can go ahead and get started at that. Let's go ahead and save our design now. And this is where it gets a little tedious, but we'll continue on. So these have all these different parts that are on here, the connectors. Wait a minute, something is wrong here. This one is bigger than that one. Why is that? Something is wrong here. Well, let's continue. I'll have to figure that out later. All right, so we're going to do some extrudes. We're going to push these down. So let's go ahead and do that. So we're going to do an extrude, and we're going to pick these. We're going to pick all these parts here. These are the 3-pin connectors. Okay, we're going to extrude those back down. We're going to extrude them by there's a height in here called connector 3-4. And I also want to subtract off this offset board reference. This is what I talked about before. We don't want the actual jig to hold the board. We don't want the board to actually meet up with the jig. We want a little bit of an offset there. So we got those done, and now I have to do these little squares. So we'll do this again, for these little parts. And I don't know what's going on with that one, but it doesn't matter. You're going to get the gist of what I'm doing. And these parts are going to go down by height header 2 minus offset board again. And we're almost done here. We'll get that one and this one. And this is height socket octal minus offset again. All right, so that looks pretty good. Now you could take this right now and print this, and it would look fine. Okay, and you can see over here under bodies, close this guy up. You can see under bodies I have one body here. But this is going to waste a lot of plastic. If we printed this now, it would weigh a lot, and it doesn't need to be. We don't need to do that. There's one more operation we're going to do on it, which is the shell. We're going to apply a shell to this surface, and we're going to I have a shell thickness here, and what that's going to do is it's going to shell out where there's unneeded parts. And I want you to notice how many bodies showed up over here. All right, so we have a bunch of bodies actually showed up over here, and you can see that if we do a section analysis and we kind of push through here, we look at this one side. Some of these parts are kind of off into space. They're kind of hanging off. That's why there's all these different bodies showed up. You know, like these things right here, these are actually hanging in free space. And that's not a problem because when we 3D print this, we're going to, in order to print these bodies in free space, there's going to be support material down in this area. There'll be support material down here to hold that in. Normally you want to get rid of the support material, but we're going to take advantage of that when we do a 3D print. Okay, now let's do the label. The label is on this side here. And so we're going to create a sketch here on this top side. And we're going to put a text on there. This is using the text tool. And we're going to pick these corners right there. And this is 8BD. And I think I used Arial Black, which is a bolder font. And I picked line center for both the horizontal and vertical. And I don't need that bold, but I do want those letters to be a little bit bigger. Now that just puts some text on there. But I have a Bamboo Lab X1 Carbon, which has I can print in different colors. So I want to extrude this into the surface here. So we'll do that first. Close this up. And we'll do an extrude. And we will pick these profiles. I think we want to pick the individual ones. Let's see if this is going to work. Yeah, that's going to work. We want to push those down. So I'm going to push those back into the design by minus 0.4, which is the height of my first layer when I print these parts. And I want these to be new bodies. And what you're going to see over here, when I hit OK, it's going to create some additional bodies. All right, so here's 8, 9, and 10. And we're going to name these. That's the B. This is the D. And this is the 8. But these exist in the same 3D space. And that's not going to, the slicer is not going to know what to do with that. So we're going to use this combine operation up here. Our target body is the entire enclosure. Our tool bodies are these 8, B, and D. And we're going to do a cut operation, and we're going to keep the tools. So now if I come over here and turn these off, what you're going to see is that it's kind of embossed these in there. And I can turn these back on again. And if I turn them on, they go away because they have the same color as this thing. So we're going to go ahead and apply some coloring to this, to those letters, so we can actually see them. And we're just going to grab some white out. Something white. This is just for visualization here. Turn these sketches back off again. Now, I made a mistake here long ago. I'm working up in the top level, and I should have been working down here in the component level. So I wonder if I can put these down there. No, I can't. I can't do that. I've messed up by creating a bunch of stuff at this top level. I should have been working down the component. But it doesn't matter. We could fix that, but we're going to keep going forward. So we'll turn the sketches off. So here's our jig. So we'll go ahead and export our design out as a mesh file. I'm using 3MF as opposed to STL. And we'll save this over here. And we're going to run the slicer. I'm going to create a new project. I'm going to name it Demo. And then we're going to import our 3MF file that we just created into here. And 3MF has a bunch of multiple objects in it. We're going to keep them all together as a single object with their positional accuracy maintained. So you can see that it's blue and yellow. So I'm going to turn off a few things. I don't need that prime tower. We want to flip this upside down. We don't want it to print in this orientation. We want to print it like this. And then I want that, you can change the colors here. So the first thing we're going to do is change that one to that. And I think we want this one to be like that. And yeah. So it's going to print this color first. So we need to flip the colors in the design. Go in here. And we're going to make that. You can see that I have 8 B and D in here. And I want those actually to be white. So I'm going to change these to white. And I'm going to change the rest of them to black. Oops, I'll change those to white. And then I want that one to this one to be black. All right, so here's I think we'll go ahead and slice this. And you see it says, it seems it has large overhangs. We should, what does it say more here? We should enable support generation. So we'll come back over here to prepare, go under global, under support, we'll turn this on. And I'm going to pick a snug style, which is minimal support to be able to print those objects. Because a lot of these are out hanging in space. We'll slice this up. And you'll see that it cost me 57 cents. And we'll look at the first layer, how it's printing. So the first thing it does, it prints all the black. And why this is important to print the black first is so that when these letters could come in and they may have problems adhering to the build plate, but the black around there will kind of attach, the white will attach to the black. And then that'll hold it all down to the plate. On the second layer, it prints the white, then it prints the black, and then the third layer, it prints over the whole thing. You can kind of see that here. So those are all covered. Now if we keep moving up into the print, you can kind of see that it's printing all these support layers underneath all those objects that are kind of hanging out in space. And eventually it goes up to the top, and it prints the whole thing. And then come over here and print it. Let's go ahead and print one, see how it goes. Make sure this is correct here. That black one is, I need to pick this guy here, which is a different printer. We'll come over here and we're going to send it to the right printer. So we got, I have 2 AMSs, and I want to use the black on the AMS number A, and my white is on number 4. So we'll go ahead and turn this on, turn those off, and we'll hit send. And so now we're going to go ahead and print one. And this print is going to take 1 hour and 8 minutes. And like I said, it cost me 57 cents. And then it gets ready to go. So we'll go ahead and watch this thing print.